Hi again. Alright, let's take a look at a series question. So, an investor is to make payments of £100 annually in arrears for 6 years, followed by £200 per annum payable half yearly in arrears for a further 6 years. The investment earns interest at 8% per annum convertible half yearly, which means that is I to the 2. And calculate the accumulated amount at the end of 12 years. So let's see how this looks. If we start here, we'll just stretch that out across. And we're starting at time 0. And let's say times 6 is about there, and 12 is about there. So essentially 1, 2, 3, 4, and 5. So we're getting £100 each time. So that looks all good until the very end of the 6th year, and then something changes. Now what happens is we're now getting £200 in the year, but it's £100 every half year. So let's take a look. So it would be, instead of doing 200 over here, we're actually doing 100, and then again a 100, and a 100, and then again a 100. So there's quite a bit more payments here, so it gets a little more confusing, and I don't think I need to continue even though I've done a lot of it. And it wants to know, what is this amount over here, this future value amount? What is that amount? We're actually asking, question mark. Okay, so what is that? Let's first start with this first 6 years, and then we'll look at this 6 years and we'll add them together. So for the first 6 years, we're just looking at a regular annuity, 100 times a to the 6, and there's no convertibles or anything, so it's really just we need to find out what this, because this is convertible half yearly, so we need to find out actually what I is over here. So to find that out, if we know that I to the 2 is 0.08, in fact I haven't written that anywhere yet, I to the 2 is 0.08, so the way that we work it out is we're going to say 0.08 divided by 2, we're going to plus a 1 to that, we're going to put it to the power of 2 minus 1, and that's going to give us our I value. So let's just use Excel to tell us what I is equal to. So it equals equal 1 plus, it's going to be 0.04 because that's 0.08 divided by 2 to the power of 2 minus 1, here we go, 0.0816. Okay, so this bit over here, it's actually 100, a to the 6th, 0.0816. Okay, cool. And in fact, this is the present value, so that's what that bit is over there. So in order to find out what the series value is, being 100 s to the 6th, 0.0816, we just have to times this by 1 plus our interest rate I over here. So I'll write that down, 0.0816 to the power of, because this is the present value that we have from this annuity over here, so we just have to compound it 12 years at that effective annual interest rate. So they're going to equal the same thing. They're the same. Okay, so now let's, oh actually this would be a 12 then. Actually, sorry, I lied, they're not really the same. There's a bit of an issue with that. So essentially this would put, if we use this would put it over here, and we don't want to know it over there. We want to then times it. So to make it be the same, we would then have to times it by another, add another 6 years to that, compound another 6 years. That's what would make them the same. So let's use this first one, because that one's easy to understand. Okay, so all we have to do is just go into Excel and calculate this number. So let's find out our annuity value. So let's start with V, and V is equal to 1 divided by 1 plus our effective annual interest rate. And now I can find out what A is equal to, 1 minus V to the power of N, which in this case is 6, divided by I, and that gives us the present value. So we can see what CA is equal to, which is £100 times that. Now that being the present value is all well and good, but now let's find out what that value is 12 years into the future. So it equals, in fact I won't call it anything, that equals, so it's the annuity times 1 plus the interest rate to the power of 12. And that looks fine, so we'll keep that number over there. And now let's do the same thing for that other annuity where we have, it's saying £200 per annum payable half yearly in arrears at the end of the year for a further 6 years. So how does that look over there? Let's just corner this bit off, and we're going to say that is equal to 200, our annuity over there, for another 6 years. And what that's going to do is going to calculate all of these values and put it back to this point. Now when I first saw this I thought, oh, it's a deferred annuity, we're going to have to figure it out back there. But that's wrong. Once we've found our present value over here, then we're just going to push it again 6 years in the future. So what we're going to do is times it by 1 plus 0.08, sorry, not point, yeah, 0.0816, which is our effective annual interest rate that we figured out, times 6 times over here. Whereas this interest rate, we're going to use I2 down the bottom, which will be 0.08. So this is kind of the same as writing 200 S2 to the 6, and this one works. So these two are the same. So let's work out what this would be using Excel. So V is the same, so we can just say it equals that one. And now our annuity is equal to 1 minus V to the n, which in this case is 6 again, divided by I to the 2, which is 0.08, convertible, so that's the annual amount convertible half yearly, gives us that. Then we can multiply it by 200, so it equals, because we're doing £200 each year, so that's that. And finally we need to find what the future value of that is. So this is really, well, I can call it CSA, because C is that a payment amount of £200, but we're doing the series. It actually wouldn't be A, it would be just CS, which is equal to that number there times 1 plus our effective annual interest rate that we use to the power of 6. And that gives us this amount over here. So let's find out what the total is here, plus the next annuity, $2,681, £81.84, 2681.84. Let's write that down somewhere. 2681.84 pounds. And that's what it is. That's how we find the answer to that question. Thank you.